Hey y'all, it's me, Miss B, and today we are simplifying rational expressions. Now this is a really important skill to have, so make sure you're taking some good notes today. So when to know if a rational expression is simplified? Rational expressions are simplified when the only common factor of the numerator and the denominator is 1. All right, and the number one most important rule when working with rational functions or expressions is simplify first. So we want to simplify first. That's really what we're working on today, is simplifying so that we can start multiplying, dividing, adding, subtracting, all that good stuff. Here's our first example. So we're using numbers that we're familiar with. Now 20 and 25, those two numbers have a number in common. That number that they have in common is 5. So I'm going to write this as 5 times 4 over 5 times 5. Okay, what happens is these 5s cancel out and we get 4 over 5 as our simplified thing. So, simplified expression. We were used to seeing it before as we would take this, we would divide this by 5, divide this by 5, and we would get 4 over 5. It's the same concept, it's just a different way of looking at it. So we're going to start thinking this way, moving forward, okay? And this is what we did before. Okay, so looking at B here, I've got x plus 3 times x plus 2 over x minus 2 over x, or times x plus 3. So before I multiply, I can FOIL this out and do all that stuff, but I can do that. But what ends up happening is this x plus 3 and this x plus 3 cancels, and so then we're left with x plus 2 over x minus 2, and we didn't even need to FOIL. Okay, let's look at C. All right, so this one's not factored for us, so we're gonna have to do a little bit of work first. So to start our FOILing process, or our simplifying process, I'm gonna factor. So x squared minus 5x minus 6, I need two numbers that add and two numbers that multiply. These two numbers need to add to be -5, but multiply to be -6. These two numbers are -2 and -3. So when I rewrite the numerator, I have x minus 2 times x minus 3. In the denominator, I have a difference of squares. So when I have the difference of squares, like a squared minus b squared, that gives me a plus b times a minus b. My perfect squares are x and 1, so I get x plus 1 times x minus 1. Okay, we factored and... oh, you know what? I didn't factor the top right. That's why things are weird. The two numbers should have been -6 and 1. So this is x minus 6 times x plus 1. Okay, so then these ones, these x plus 1s are going to cancel. And so we're left with x minus 6 over x minus 1. All right, finally, our numerator is already factored, but let's go ahead and factor our denominator. So two numbers that add to be 1, two numbers that multiply to be 2. 2 times -1 gives me -2, and 2 plus -1 gives me 1. So this factors to be x plus 2 times x minus 1. These x plus 2's cancel, and when I have everything cancel in the numerator, I do have an invisible 1. So it's going to stay, that invisible 1 will stay, and this is just 1 over x minus 1 for that final answer. Okay, so when everything in the numerator cancels out, you're left with 1. Okay, so we'll leave those 2 last examples for class. That's all for